All right, guys. So this is the video for chapter 20 where we're balancing redox reactions. Everybody has this in front of them, right? We are going to balance this equation right here. Okay. So I'm going to go through each individual step so you guys know exactly what each of these steps mean. And you really shouldn't skip steps. Okay. I really broke it down so that this becomes easy. So if you skip steps, it becomes hard, right? So follow the steps as is written and everything should be fine. All right. So this method for balancing redox reaction, yeah, remember what redox is? We went over it in last chapters, reduction oxidation. So it's different than just a regular equation because you see it has charges, right? When you're balancing a regular equation, you don't have charges to worry about. So it's harder to balance this kind of equation, and that's why we have a method for doing it. So the method is called the half reaction method. You're gonna split these up into reactions, half reactions. And the way you do that is notice the thing on the left and the right side that's the same, and that becomes one half reaction. So I see the chromium, and for now you can leave out the state of matter. We can add that back in at the end. Okay, so you don't have to write aqueous for me. Okay, so that's one half, right? Now the second half is HNO2 to NO3 minus. Okay. You guys see that, right? So things that are similar, they become the half, right? So that's step one. Divide the reaction into half reactions. Now step two has 4 parts to it, right? You can see that 4 parts. So we'll call them A, B, C, D, okay? So step 2A, it says balance atoms other than oxygen and hydrogen first. Okay. Do we have atoms that are other than oxygen and hydrogen? Yes. What is it? Chromium. Right. And is chromium balanced right now? No. So what do we do to balance chromium?
Is that a part, CR2?
Mhm.
Oh,
Yeah, CR2. Yeah. So what do we do to balance the chromium? Two in front of CR3 plus. Right? And then B, it says balance the oxygen atoms with water. Okay. So why do we do this? Notice that for a lot of these, it will ask you to balance it in acidic solution or basic solutions. Do you guys remember what acidic solution is? What is an acid? It leads with H, which are protons, right? So when you're in acidic solution, you have water, right? And you also have H plus. Okay. So that's what you're using to balance the equation. Water to balance the oxygen, and to balance H, use H plus. Okay. And then I'll show you as well in basic solution what happens. Okay, but we're just gonna do an acidic solution first. Okay, so step 2B, it says balance oxygen atoms with water because there's a lot of water around, right, in acidic solution. So how many oxygens do we have on the left side right now? 7. And on the right side, how many? None. So how many waters should I add and to which side? 7 to which side? To the right side. Like that, right? Because now you have 7 oxygens on the right side. Okay. And then step C, 2C, balance H with H plus. Okay. How many H's do we have on the right side? 14. How many on the left side? None. So what do we need to add to the left side? 14 what? H what? Plus, right. Why? Because it's an acidic solution, right? And it says right there, balance H atoms with H plus. Okay, because that's what you have, right? H plus, 14H plus CR2O7 2 minus. goes to 2Cr3 plus 7. Making sense so far, guys? Right? According to the steps. Okay. So once I get done with that, I go to 2D. Now you balance the charge by adding electrons. Okay. Electrons are what charge, everybody? Negative. Okay. So think you can only add negative. Okay. First, you have to count the charge on each side. So what is the net charge on the left side? We have how many pluses? 14 pluses. And how many negatives? 2. So what is the net? 12 positive. Make a little note to yourself. How about the right side? What is the net charge? 6. Right, 6 plus. Okay. So write a little. Okay. So remember, we can only add electrons, which are what charge? Negative. So would it make sense to add electrons to the left side to bring this down to 6? Because right now they don't match, right? You're trying to balance it. So how many electrons should I add to the left side to bring this down to 6? 6. Right. So I'm going to add 6 electrons to the left side. Okay. See how we figure that out? So now 6 minus and 2 minus is 8 minus. 8 minus and 14 plus is 6 plus, which balances out with 6 plus on the other side. Okay. So you see that in step 2, what we did was we balanced the atoms first, and then the final thing is balance the charge. Okay. So this is why it's different, right? This type of balancing reaction is different than just a simple balancing equation, right? Because you also have to balance the charge. All right, once you complete step 2 for one of the half reaction, you go and you repeat it for the second half reaction. Okay, so let's do it again. Step 2A. Right, so step 1. Step 2A, balance atoms that are not oxygen and hydrogen first. Do we have non-oxygen and hydrogen atom? Would be what? Nitrogen. But is it balanced? Yes. You're like, okay, good. All right, move on, right? Balance oxygen atoms with water. Okay, guys, so tell me, where should I add the water? Into which side? And how many? What? Yeah, you only need one, because you already got 2 here, right? How many do you need on the right? Like, how many on the right side are there? 3. 3. So here's already 2, so you just need to add how many? 1. Just 1 water plus HNO2 equals to NO2 minus, right? Now the oxygens are balanced, yes? Now you balance the hydrogen. How do we balance hydrogen? By adding what? H plus. Okay. So to which side should I add H plus? And how many? 3. Yep. Three what? H plus. Make sure you add H plus. Okay. Hydrogens are balanced now, right? Now we balance the charge. Okay. Net charge on the left side, everybody. What's the net charge on the left side? Yeah. What's the net charge on the right side? Yeah. How can you tell? 3 times plus is 3 plus, right? And this is just 1 times minus. So 3 plus and a 1 minus is 2 plus. Which side should I add the electrons? Left or right side? Right side. Yeah, always add it to the side that is higher. right? Because you need to bring it down. So how many electrons should I add to the right side? 2, right? Because a 2 minus and a 2 plus will bring you down to 0, right? That's how you figure it out, right? Okay. Now we're done with step 2 for both. So let's move on to step 3. Okay, step 3, what does it say? Multiply half reactions by integer necessary, if necessary, so that the number of electrons gained is equal to the number of electrons lost. Okay, so what is meant by that? On the left side, you have 6 electrons, right? On the left. Okay, that means this is gaining of 6 electrons, right? But over here, we have electrons coming on the right side of the equation. That means electrons lost. Does that make sense? Right? So we have 6 electrons gained and 2 electrons lost. Are they matching right now? No. So that's what it's meant by number 3. Multiply half reactions by integer so that they match. So which one can we multiply by and by what factor to get those numbers of electrons to match? Left side, which side? Right side by 3. Right. Okay. So we multiply this by 3. Okay, so here's step 3. Then we have to multiply everybody by 3, right? So 3 times 1 is 3. So that's 3 water. Plus 3 HNO2 goes to 3 NO3 minus. Plus, what's 3 times 3? 3 times 3 is 9 protons. And 3 times 2 is 6 electrons. Okay. All right. So does it match now, guys? Are we done with step 3? Because 6 electrons on the left, and you also have 6 electrons on the right side. Okay. Okay, and by left and right, I mean of the equation, right? Here the 6 electrons are coming on the left side of the equation, and here the 6 electrons are coming on what? The right side of the equation. You need it to match. And then step 4, you're gonna combine now, right? Because you split it up before. This is where you can combine. So it says add half reactions together, canceling molecules that appear on both sides. Electrons should always cancel. So to make it easy, I just rewrite what I had. So 3 water plus 3 HNO2 goes to 3 NO3 minus plus 9H plus 6. So I just rewrite it so they're both on top of each other. So it makes it easy for me to add it together. So things that occur on both sides, they can cancel, right? So 6 electrons here can cancel with 6 electrons there. What else can cancel? What's that? What are things that occur on both sides? Are those exactly the same thing? I'm saying exactly the same thing. What do you see that are exactly the same on the left and the right side? How many on the left? Where? Yeah, they need to be exactly the same. Come on, guys. Which ones? Exact same compound. Do you see things on the left that is exactly like on the right? H2O. How many on the left side? And how many on the right side? Okay, so how can that cancel? 3 here, and what's 7 minus 3? You have 4 left here. Okay. What else? Say that again, Gina. Right. Not hydrogen. What is it called? Proton. Because what's hydrogen? It's just what? Hydrogen is just H. What's a proton? H positive, right? Okay. So how many protons on the left side? How many on the right side? Okay, so how do they cancel? And then how many left here? 5. Okay. So that's what's meant by step 4, right? Add half reactions together, canceling molecules that appear on both sides. So now you have 5H plus left, plus Cr2O7, 2 minus, plus 3HNO2 goes to 2Cr3 plus 4H2O, plus 3NO3 minus. All right, does that make sense, guys? Step 5. Are you sure, Victor? Okay. Check, step 5, check that the atoms and charges balance. Okay, so how many chromiums do we see on each side? And how many oxygens do we have on each side? Got 7 here. And then how many here? 6, right? For a total of 13. And on the right side, how many oxygens do we have? 13 as well. We're good, right? Let's count the hydrogens. How many hydrogens on the left side? 8. Okay. And how many on the right side? 8. Very good. Now the charges. What's the net charge on the left side? How many pluses do you have? 5. How many minuses do you have? 2. So what's 5 minus 2? 3 what? Plus. Okay. What is it on the right side? Three plus as well, right? 6 plus, 3 minus. Don't forget the coefficient in front, right? It's telling you there's 2 of this, and each of them is what? 3 plus. So total is 6. And this, each of these is minus, but there's 3 of them, so 3 minus. Okay. So we good, right? So you would be done if this problem said balance in acidic solution. Okay. But what if this problem says balance in basic solution? You follow the rest of the steps. Okay, so let's do it. So it says in basic solution, you still have water, right? But you don't have H plus because this is acidic, isn't it? So in basic solution, you have hydroxides. That's what a base is, okay? Hydroxide is OH minus, right, everybody? Okay, so what happens is the OH minus will eat up the protons and make water. You guys see that? OH minus and H plus. They combine to make what? H2O. Minus and plus is neutral. Okay, so that's why it says do steps 1 through 5, we just did. Then add as many hydroxides as there are protons. So find the protons in your equation. How many? 5. So you're going to add exactly 5 hydroxides. But this is balanced, yes? So if you add hydroxides to the left side, you better add it to the right side as well. Otherwise, you unbalance it, okay? So I'm going to also I'll write this up here. Add 5 hydroxides to the right side, okay? But I can simplify this now. We know that 5H plus and 5OH minus makes what? What does H plus and OH minus make? H2O, and how many? One of these and one of these makes how many water? I mean, one OH minus, right? And H plus makes how many water? What? Yeah. So 5H plus and 5OH make 5H2O. Right? It's 5 waters. So now it says cancel the excess water, right? You see waters we can cancel? On the right side, how many waters? And on the left side, we just had 5. So this one can cancel, and how much left over do we have over here? Just 1, right? So we can rewrite it so it looks nice, right? 1 water plus Cr2O7 2 minus plus 3HNO2 goes to 2Cr3 plus 3NO3 minus plus 5OH minus. Okay. Now, this is the answer for basic, right? Let's check. How many chromiums on each side? Let's count. Yep. How many oxygens on each side? How many oxygens total on the left side?
14.
Yep. And on the right side? Oxygen is total. 14. How many nitrogens total on the left side? 3. And on the right side? 3. So we're balanced with nitrogen, oxygen, and chromium. We haven't checked hydrogen, right? How many hydrogens on the left side? 5. And on the right side?
5.
All right, atoms are balanced. What's the last thing we check? Charges. Net charge on the left side. Left side, what's the net charge? What charge is H2O? Yeah. What charge is this one? Yeah. And what is charge is this one? Right. So what's the net charge on the left side? 2 negative. Yeah. What's the net charge on the right side? What is this one? What's the net charge of this one? 6 plus. And this is 3 minus, right? So what's 6 plus and 3 minus?
0.
6 plus and 3 minus? No. Positive 3. And what is this one? Not a -1. What is it? Yeah, there's 5 of them. So what's the total minus? 5 minus. And you had what? 3 plus. So what? 2 negative. Which balances out with? Yes. This one?
5, yeah. You don't end up with 5 H, so
You do, but then remember we had 4 waters on the right side that we canceled with. Mhm. Yeah, just to simplify it, you know. Otherwise, you'd be writing 5 waters here and 4 waters over there.
Oh, that's good.
It's just like more concise, right? Yeah.
It's basically, yeah, so it's already 4, right, so just made it.
Yeah, well, we can cancel, right? Because we have 4 on the right, but we have 5 on the left. So what does that mean? We have a net of just one on the left, right? So that's what I mean by root cancel. So it's like math, right? Like if I had like yeah, plus one or something. Okay. So what can you do to simplify? With 2x over here, with 3x there, so what can you do? 2x, and this becomes just what? X. Right? It's like so. Yeah, you see how we did it here, right? We have 14 on the left and a 9 on the right. So cross out the smaller number and then subtract it from the larger number on the other side, and that's how much you have left on the other side. If it was exactly the same, 9 and 9, then what? Just cancel out entirely, right? Yeah. Okay, any questions, guys? Yeah. Yeah, we can do another one. And then you guys have the worksheet to move on to. Okay. Find a good one here. Okay, let's do this one. SO3 2 minus aqueous plus MnO4 minus aqueous goes to SO4 2 minus aqueous plus. And it's all recording right now too, so you guys can always go back and look at it. All right, so first step, guys, what do we do? What does this say? Divide the reaction into half reactions. So what's one of the half reactions? What should I put with what? Right, very good. Like that, right? And you can leave out the states for now, right? SO3 2 minus goes to SO4 2 minus. Okay, what's the other half? Minus goes to plus. And then step 2, hey, what do? It says balance atoms other than oxygen and hydrogen first. What do we have? That's other than oxygen and hydrogen. Sulfur. Is it balanced? Yeah. Cool. Step A is done. B, what does it say? Balance oxygen atoms with water. Where do we put water and how many? What's that? Water is what? Okay, how many? And on which side? What's that? Yeah, I mean, like, it says balance oxygen atoms with water, right? So where should you put water and how many? What's that? Like, which side should you add water?
Oh,
To balance the oxygens, right? Okay, and how many? Yeah. Why? Because you already have 3, and you only need how many? Just 1, so you have 4. Yeah. Okay. And then it says balance hydrogen with H plus. All right, so guys, where should I put H plus and how many? Very good. 2 on the right side. Okay. And then we balance charges, right? By adding electrons. So left side's net charge is minus. Yep. Write yourself a little note. Net charge on the right side. So to which side should I add electrons? How many? Because the electrons are negative, right? Remember, you want to add it to the higher side to bring it down to the other number. So you're gonna add 2 electrons over here. Yes? Okay, let's do it for the other half reaction as well. Balance oxygen other than oxygen hydrogen. We have atoms other than oxygen hydrogen? Yes. Is it balanced? Yeah. Go to B. Balance oxygen with water. So how many water should I add and to which side? 4 on the right side. Very good. Everyone still following, right? Makes sense? Okay. And step C says add balance the hydrogen by adding protons. How many protons should we add and to which side? 8. Very good, Nadia. To which side? Left. Okay. 8 H plus MnO. Okay. And then D. Net charge, right? Figure out net charge. Left side's net charge. And on the right side? 2 positive. Where should we add electrons? How many? Very good. So we Alrighty. And step 3, it says multiply half reactions by an integer if necessary, so that the number of electrons gained equals the number of electrons lost. Okay, so I got a 2 and I got 5. Remember, I need to make those match. So think about what number I can multiply to get those to match. What do you guys think? Like, say again. Right, 10. So I should multiply this one by 5, and I'm should multiply this one by. There you go. Make sense? Right? Right? 5 times 2 is 10. 2 times 5 is 10. Okay. So 5 H2O plus 5 SO3 2 minus goes to 5 SO4 2 minus plus 10H plus 10 electrons. And then over here, 2 times 5, 10 electrons, 2 times 8, so 16 protons, 2 times 1, so 2 MnO4 minus, 2 Mn2 plus, and 8 H2O. Make sense? You guys following? Okay. Now what? Step 4, we're gonna add it back together, right? So remember the trick? Just put one underneath the other. This makes it so much easier to see. So I'm just copying that one right underneath this. Okay. Can you guys right away see the 10 electrons cancel, right? What else can cancel, everybody? Uh-huh. And how would you do it, Donovan? 3 left on the right side, yeah. Okay. What else? Protons, right? That's right. 10 completely cancels on the right. And here you have 6 left. And so now you just drop it down, right? Everything that's on the left side, put it on the left side, right? So we have 5 SO3 2 minus. We have 6 protons. We still have this 2 MnO4 minus. That's on the left side. Arrow. Now everything on the right side, right? 5 SO4 2 minus plus 2 Mn2 plus 3 H2O. Okay. So this would be an acidic. If it prompts you an acidic, you stop here, right? And you just check everything. How many sulfurs on each side, guys? 5. Okay. How many oxygens? 15 plus 8, 23. Okay. And here, 5 times 4 is 20. And that's a 3. So 23 oxygens on each side. How many hydrogens on each side? 6. Okay, we good. How many Mns? How many manganese? 2. Okay, we're good. Now do charge. Net charge on the left side. Hmm, 10 minus, 2 minus, and 6 plus. Yep, -6. And on the right side, 10 minus and a 4 plus. -6. Okay. All right. But what if it says in basic solution? So then what do you do? Right. Find the protons. How many do we have? So then we have to add how many? 6. OH minus. Okay. We add it to the left side. We also have to add it to the right side. We gotta keep it balanced, right? But then this simplifies to what? Huh? 6 what? H2O, exactly. So can we simplify further? This the waters?
Yeah.
Okay. So then our final answer down here, 5 SO3 2 minus plus 3 H2O plus 2 MnO4 minus goes to 5 SO4 2 minus plus 2 Mn2 plus 6 OH minus. Okay. All right. You guys see that? The difference, right? In acidic, you have protons left, right? But in basic, what? You have hydroxide, right? Because if you have a basic solution, protons will not survive, right? Yeah. Just like we did up here, right? Canceling things out on both sides that are the same, right? Yeah. We had 3 waters on the left side, and we had how many on the right side? Yeah, 3 waters on the right side. How many do we have on the left side? 6. So then 3 is gone from there, and then you have 3 left over on the left side. Right? Okay. Again, just more simple than just writing 6 water over here and 3 waters over there. Okay? Yes.
This is basically like utilizing spaces or.
Yeah, right here. Yes.
Okay.
Because it's dependent on what it's asking you, right? So in acidic solution, yes, protons will be there. Because that's what an acidic solution is, right? But it's saying, if it says balance in basic solution, in a basic solution, protons can't survive. Why? Because what is present in a basic solution? Hydroxide. So anytime that a proton's around, the hydroxide would do what? Cancel, neutralize it, to turn it into H2O. And so that's why when it says do it in basic, protons cannot, this cannot be your answer. Okay? You have to do this step. Because it makes sense to only have hydroxide in basic solution. That's why you have 2 different answers depending on what it is. Yes.
If it's acidic, could leave it in box.
Yeah. If it was acidic, you'd stop here. But if it says balance in basic, then you do what? 1 extra step? 2 extra steps? Yeah. All right. Let's